Have you ever looked up at the night sky, truly gazed into its infinite depths? It's a humbling experience, isn't it? A canvas of countless stars, swirling galaxies, and cosmic mysteries that stretch beyond our comprehension. And as you lose yourself in that celestial tapestry, have you ever wondered where it all began? What sparked this grand cosmic dance? What is the origin of everything we see and everything we can't even imagine? The human mind is naturally curious, always seeking answers to the biggest questions. We instinctively search for a center, a point of origin, a place from which all things emanate. It's a deeply ingrained human tendency to seek order and structure, even in the face of the seemingly chaotic universe. A cosmic X that marks the spot, a definitive location that provides a sense of grounding and understanding in the vastness of space. We want to pinpoint the heart of it all. It feels natural to assume, doesn't it? To believe that there must be a central point, a prime mover, a singular source from which everything else has sprung. The universe must have a special point, a privileged location that holds the key to understanding its very essence, a place of ultimate significance, from which everything radiates, a source of energy, matter, and the very fabric of space-time itself, a cosmic beacon illuminating the darkness. For centuries we placed ourselves at that center, convinced of our unique position in the grand scheme of things. We built our cosmologies around this idea, shaping our understanding of the universe to fit our own perceived importance, believing everything revolved around us, the sun, the moon, the stars, all dancing in orbit around our home, confirming our central role in the cosmic drama. This geocentric view was more than science. It was a fundamental part of our worldview, shaping our philosophy, religion, and even our sense of identity. It was our anchor, providing a sense of stability and purpose in a vast and often frightening universe. It was a comforting narrative that placed us at the heart of creation. But what if this need for a center, this inherent desire to find a single, definitive point of origin, is actually leading us astray? Has blinded us to the universe's true nature? Could our preconceived notions be preventing us from seeing the cosmos as it truly is? The cosmos doesn't play by our rules. It doesn't conform to our expectations or adhere to our human-centric biases. It's a realm of infinite possibilities where the unexpected is the norm. Our journey to find the universe's center, this quest for the ultimate cosmic address, is not just a scientific endeavor. It is really a journey of perspective, a process of constantly re-evaluating our place in the cosmos and challenging our deeply held assumptions. We've moved from seeing ourselves as the main characters, the stars of the cosmic show, the center of all creation, to realizing we're part of a vast, interconnected ensemble, a single thread in a tapestry of unimaginable scale and complexity. Let's explore ancient ideas, the wisdom and misconceptions of those who came before us, their attempts to map and understand the heavens. Modern discoveries, the groundbreaking insights that have revolutionized our understanding of the universe, from the Big Bang to dark matter, and ultimately confront a profound truth, a truth that may challenge everything you thought you knew about the universe and our place within it. The center of the universe is both everywhere and nowhere, a paradox that defies our intuitive understanding of space and time. Prepare to have your cosmic address book rewritten. Get ready to discard old maps and embrace a new way of seeing the universe. The universe is waiting, beckoning us to explore its mysteries and expand our understanding of reality. Are you ready to answer the call? For most of history, the answer to where is the center of the universe was simple right here, on Earth. Ancient civilizations built models with Earth at the heart, surrounded by celestial spheres. The sun, moon, and stars all seemed to revolve around us. Ptolemy's geocentric model predicted planetary motions and fit our beliefs. This idea shaped art and religion and society for centuries. The stars were thought to be tiny lights marking the edge of our world. The geocentric model wasn't just science, it was a worldview that gave us comfort and meaning. But science thrives on new evidence. As observations improved, cracks appeared. To explain odd planetary motions, the model became convoluted, with orbits on top of orbits. The universe was hinting that something was wrong. A few brave thinkers began to listen. Change was coming. The Renaissance brought a seismic shift, a period of intellectual and artistic flourishing that challenged the established order. It was a time of questioning, exploration, and a renewed interest in classical knowledge. This era marked a departure from the medieval focus on religious dogma, paving the way for new scientific discoveries and a re-evaluation of humanity's place in the cosmos. At the heart of this shift was Nicholas Copernicus, who dared to propose a sun-centered solar system. This heliocentric model placed the sun, rather than the Earth, at the center of our planetary system, a radical departure from the long-held geocentric view. The Copernican model was simpler mathematically, offering a more elegant explanation of planetary motions, but it was also deeply unsettling. It challenged the authority of the Church and the prevailing understanding of humanity's significance in the universe. Galileo Galilei's groundbreaking use of the telescope provided further evidence supporting the heliocentric model. His observations revealed moons orbiting Jupiter, demonstrating that not everything revolved around the Earth. He also observed the phases of Venus, which could only be explained if Venus orbited the Sun. These observations were a direct challenge to the geocentric model. Galileo's discoveries shattered the old worldview, dismantling the long-held belief in an Earth-centered universe. The implications were profound, shaking the foundations of science, religion, and philosophy. Further scientific advancements revealed that the heavens were not made of some ethereal substance, but of the same stuff as Earth, composed of the same elements and subject to the same physical laws. As our understanding of the cosmos expanded, we lost our central spot, our privileged position at the heart of creation. But in losing that position, we gained a truer understanding of our place in the universe, a more accurate and nuanced perspective on the cosmos. Yet even as we embraced this new understanding, we still searched for a center, a point of reference in the vastness of space. The human mind seems wired to seek out patterns and hierarchies. Perhaps the sun, the source of light and energy for our solar system, could be that center. It seemed a logical choice, given its dominant role in our local cosmic neighborhood. Or maybe the center of the Milky Way, the swirling mass of stars, gas, and dust that constitutes our home galaxy, held the key. For a while, astronomers thought our sun, and therefore our solar system, was located at the galaxy's heart, residing in a privileged position at the center of the Milky Way. But Harlow Shapley's meticulous observations of globular clusters showed that we're actually in a spiral arm, far from the galactic center. We were relegated to the suburbs of the galaxy, far from the perceived center of activity. Then, in the 20th century, Edwin Hubble made a monumental discovery that the universe is not just one galaxy, but is filled with countless galaxies, each containing billions of stars. The universe wasn't just one galaxy, our Milky Way, as previously thought. It was a vast ocean of galaxies, stretching out in all directions, an almost incomprehensible expanse. The idea of a single central point, a cosmic bullseye, became increasingly impossible to defend in the face of this overwhelming evidence. Each discovery, each new observation pushed us further and further from the center, challenging our assumptions and expanding our horizons. Our cosmic address kept changing, reflecting our evolving understanding of our place in the universe. The search for a center, a fixed point in the cosmos, was gradually unraveling, revealing a universe far more complex and dynamic than we had ever imagined. The universe was bigger and stranger than we'd ever imagined, filled with mysteries that continue to challenge and inspire us. The next revelation, the next paradigm shift, would be even more profound, forcing us to confront the very nature of reality itself. Edwin Hubble, a name synonymous with cosmic discovery. His relentless pursuit of understanding the universe led to one of the most profound revelations in the history of astronomy. Hubble's observations revealed that the universe isn't static, as previously believed, but is in fact expanding. This groundbreaking discovery reshaped our understanding of the cosmos and laid the foundation for modern cosmology. He noticed that galaxies, those vast islands of stars, are not stationary. Instead, they are moving away from us, and from each other. This wasn't just a random scattering, but a systematic recession. And here's the truly astonishing part. The farther these galaxies are from us, the faster they appear to be receding. This relationship, now known as Hubble's law, provides compelling evidence for an expanding universe. It suggests a universe that was once much smaller and denser. Now let's engage in a bit of cosmic time travel. Imagine running the clock backward, winding back the history of the universe. As we rewind, the galaxies get closer and closer, the space between them shrinking until everything converges into an incredibly hot, dense state, a state far beyond our everyday comprehension. This brings us to the Big Bang, the widely accepted theory for the origin of our universe. But it's crucial to understand that the Big Bang wasn't simply an explosion space like a firework bursting in the night sky. Instead, it was an explosion space itself. It was the very fabric of space-time that was expanding and continues to expand to this day. Space, as we know it, didn't exist before the Big Bang. It began at the Big Bang, emerging from that initial singularity, and from that moment onward, space has been relentlessly stretching, carrying galaxies along with it in its ongoing expansion. This concept can be difficult to grasp, but it means there's no outside the universe, no external realm into which it's expanding. The expansion isn't just about objects moving through space, it's about space-time itself, the very fabric of reality, expanding. Furthermore, there's no single special point in space that can be identified as the center of this expansion. To illustrate, imagine a room where the very structure of the room itself is expanding, the walls stretching outward. In such a scenario, every point within the room would be moving away from every other point, creating a uniform expansion. In a similar way, the Big Bang didn't happen at one specific location. It happened everywhere in the universe simultaneously. Every point in the universe that we observe today was once part of that incredibly dense, hot singularity. Therefore, the origin of the universe isn't a specific place we can point to. It's an event, a cosmic happening that occurred everywhere at once, encompassing the entirety of what would become our observable universe. Consequently, no single location within the vast expanse of the cosmos can rightfully claim to be the center of the universe. The Big Bang, the event that set everything in motion, unfolded across the entire cosmic fabric, simultaneously affecting every point in space-time. Grasping this concept, letting go of the idea of a universal center, is absolutely key to truly understanding the nature and evolution of our universe. It allows us to appreciate the grand scale and the interconnectedness of everything within it. Picture the expanding balloon analogy. Draw dots on a balloon. Each dot is a galaxy. As you inflate the balloon, every dot moves away from every other dot. From any dot's perspective, it's the center of expansion. But the surface has no center, just like our universe. The expansion is a property of space itself, not a movement from a central point. The raisin bread analogy works too. As the dough rises, every raisin moves away from the others. No single raisin is the center. Our universe expands everywhere, uniformly. The center is an illusion born from our perspective. Here's a cosmic truth. You are the center of your observable universe. So is everyone else, everywhere. Since every galaxy moves away from every other, every observer appears to be at the center. Imagine standing in an infinite crowd. Everyone steps away from their neighbors. From your view, you're at the center, but so is everyone else. This is the Copernican principle. No privileged position. Your observable universe is a bubble defined by how far light has traveled since the Big Bang. The edge is your cosmic horizon. Someone in Andromeda has their own bubble centered on them. You're at the center of what you can see, not the center of everything. It's like being on a boat in the ocean. Your horizon is centered on you, but so is everyone else's. No one is at the center of the ocean. We're each at the center of our own cosmic view. Is there evidence the Big Bang happened everywhere? Yes, the cosmic microwave background, or CMB. For hundreds of thousands of years, the universe was a hot, dense plasma, opaque to light. As it cooled, atoms formed, and the universe became transparent. The CMB is the afterglow from that moment, a snapshot of the baby universe. We see this ancient light from every direction. The CMB is astonishingly uniform, no sign of a special direction or center. If there were a center, the afterglow would be brighter in one direction. Instead, it's smooth, confirming the Big Bang happened everywhere. Tiny fluctuations in the CMB seeded galaxies, but the overall uniformity is key. The CMB is the cosmic echo of an origin that happened everywhere. We've moved from an Earth-centered cosmos to a universe with no special place for us. The question, where is the center, is flawed, like asking for north at the North Pole. In an expanding universe, every location is the center of its own observable frame. Einstein's relativity tells us there are no privileged reference frames. The hunt for a cosmic center ended, not because it's too hard, but because it's meaningless. The fabric of space-time is dynamic and relative. The universe is magnificent from every vantage point. We found something more profound, a consistent, uncentered universe. Accepting a universe without a center is a leap, but it's a beautiful one. Science is a journey of shedding biases to see the cosmos as it is. Cosmology is still full of mysteries, dark matter, dark energy, the universe's true shape. Our quest continues, driven by curiosity. Each discovery leads to deeper questions. So next time you look up, remember, you're at the center of your own observable universe. The universe's majesty is accessible from everywhere. The adventure is in the journey. Keep looking up.